Now, this one's a pretty interesting statement. I mean, only in trig where you can take the identical pieces. Oh, you guys can't see that very well. And what does this statement say? This statement says if you subtract these two pieces, it's the same thing as multiplying these two pieces. So that's a pretty interesting statement. It's a pretty interesting identity. So my usual hint, start with the side that looks more complicated. I mean, they're both simple and plain looking, but I typically like to pick the side that has more pieces, more terms to play with, and that's going to be the left-hand side. Now, using my hints, look at the end goal as a guide. Notice how the end goal uses cotangents and cosines, and that's exactly what we start with. So on the face value, it looks like I don't want to change my pieces. But I got to be honest with you, I have no idea how to transform a subtraction problem into a multiplication problem. That's basically what this identity says. So it seems like we're going away from the goal, but I'm going to be honest, I have no idea what to do. So my hint, when your back's to the wall and you have no idea what to do, change everything into sines and cosines, and that's exactly what I'm going to do first. So we know that cotangent squared is cosine squared over sine squared. Now we have adding, subtracting fractions, so I can go ahead and get the common denominator. So this guy here needs a sine squared on top and bottom. So that's cosine squared minus cosine squared sine squared all over sine squared. Let's see here. Now that I group these guys together as one numerator, I notice that they both have a cosine squared. So in math, when you have two pieces that contain the same thing, you can factor him out. Now we recall, so this is my scratch work, or this is my thinking, our Pythagorean identities. We know that cosine squared t plus sine squared t equals 1. So if I subtract the sine squared over, I should know that that guy there, 1 minus sine squared t, that is precisely cosine squared. And notice what we also have here. We have cosine squared over sine squared. That, by definition, is cotangent. I think we're done. We got it. So this is cotangent squared. And then this piece here we said was cosine squared, which is the right-hand side. So pretty neat concept, pretty neat identity. If you have a cotangent squared and you have a cosine squared and you subtract them, it's the same thing as multiplying them. Who would have thought?